So welcome to this latest video 162 Maths, and in this video we'll be going over the GCSE Maths topic of iteration with a focus on introducing the concept of iteration and knowing how to find U2, U3 or x1, x2, x3 values from an iterative formula. Now, an iteration is a type of sequence in that it produces a term-by-term series or sequence of numbers. Now, whereby an arithmetic or a geometric or a linear or quadratic sequence, etc. can be represented by a formula where the value of a term is determined by its position in the sequence. An iteration, the value of a term is dependent on the previous result. Now, it kind of works in a very similar way to the Fibonacci sequence. Now, in the Fibonacci sequence, the official Fibonacci sequence starts with 0 and 1, and how you find the next term is by adding the previous two terms together, in which you're always given two starting values, and in a Fibonacci sequence you add the previous two. So this third term will be the sum of the first and the second term, so that's going to be 0 plus 1, which is 1. Then the next term is going to be the previous two terms, which in this case is 1 and 1, which is 2. Then the fifth term rather is going to be the third and the fourth term, so that's going to be 1 and 2, so 1 plus 2 is 3. The next term is going to be the previous two terms, which in this case is 2 and 3, so that's going to make 5. And then the next term is going to be the sum of the previous two terms, which in this case is going to be 3 and 5, which is 8. So again, the iteration works in a similar process. And just to recap, whereas with an arithmetic, a geometric or linear or quadratic sequence where the value of a term is based on its position, in an iteration it uses all the some previous terms. So it all depends on what values you're starting with to decide what numbers would actually go in a sequence. So now let's just try and emphasize that point. So here we've got a linear or arithmetic sequence, and the definition of a linear or arithmetic sequence is where it's got a common difference between each term in the sequence. So in this particular sequence we can see that the difference between 3 and 10 is 7, and you can see that between each term all I'm doing is adding 7. So when you've got this common difference, regardless of whether it's adding or subtracting, it's going to be what we call a linear sequence or an arithmetic sequence. Now, in a quadratic sequence, this has a common double difference between each term. So here, if I look at the difference between 5 and 8, well, that's going to be plus 3. The difference between 8 and 13 is plus 5. The difference between 13 and 20 is plus 7. And the difference between 20 and 29 is plus 9. But then if I then look at the difference between the difference, then what I end up with is plus 2, and plus 2. And because this is these double differences are the same, that's why we can class this as being a quadratic sequence. Now, in a geometric progression, there is a common ratio, so there is a common multiplier between one term to another. So here, rather than adding, what we're doing is we're multiplying by 2. So in a geometric sequence, the ratio between two consecutive terms is the same. So for example, if I take two consecutive terms, so let's say the first two, if I do 12 divided by 6, that gives me an answer of 2. And if I pick another two consecutive terms, this time 96 and 48, and I do 96 divided by 48, again that will give me the same common ratio. So there is an example of a geometric progression. Now, in a Fibonacci sequence, again, it starts with two initial terms, and the next term is the sum of the previous two. So here we don't have to start with 0 and 1. Here we're starting with 2 and 5. So if a question asked me to find the next 4 terms of this Fibonacci sequence, all it needs to say is Fibonacci sequence. It doesn't have to sort of reiterate the original Fibonacci sequence, which started with 0 and 1 as previously mentioned. You can actually start with any two numbers. So here the third term is going to be 2 plus 5, which is 7. The next term is going to be 5 plus 7, which is 12. The next term is going to be 7 plus 12, which is 19. And then the sixth term is going to be 12 plus 19, which is going to give me 31. Now we'll go into more detail about an iterative process, but it seems like an apple point of when we actually start introducing it. So in an iterative process, you always tend to start and given a particular value. So this here is our first term in the sequence. Now this here, which involves un plus 1 and un, which we'll go into more detail later on this video as to what this is. This here represents the formula. So the formula to find other terms, and then in this particular part here is basically what the question's asking you to find. So what the question is asking you to find. Now, so here, what we've got here, this will explain the breakdown of the actual formula with regards to what's un plus 1 and what's un. So u2, if we know u1, then u2 is going to be our second term, u3 is going to be our third term, and u4 is going to be our fourth term. So what we know so far in this is that if I just write down 4 blanks, then I know that the first term is 2, and the question is asking me to find the second term. This is where u2 would be, this would be u3, and this would be u4, and there would be u1. Now in terms of notation, now this is what usually often confuses students, is because this is completely new notation that you would never have seen in lower down school. Now, just like in all other sequences in maths, n represents the position of a term in a sequence. And with iteration, n is no different. So the first term is going to be when n equals 1, the second term is when n equals 2, the fifth term is when n equals 5, and the 10th term is n equals 10. So in an iterative process, u1 represents the first term, u2 represents the second, u3 represents the third term, etc., as previously mentioned. Now, in terms of the notation, because obviously an iteration sequences uses previous terms, they can't use n equals 2, n equals 4 into the formula, because it just then becomes confusing. Because when you have n equals 2, you'll then end up having, like with an nth term, you might have something that looks like where you might have 4n plus 3, but then if the second term is n2, then your formula will look like this, which then starts getting really, really messy. So that's why we tend to use this notation instead. Now, if un is the current term, then un minus 1 is the previous term, and un plus 1 is the next term. So again, because obviously if you try to write down, let's say, the Fibonacci sequence in the form of a formula, because it's a general verbal rule, it's really difficult to actually note down in terms of using algebra. So instead, what would make it helpful is using this. So here, if we were to write down the Fibonacci sequence, it would look something like that. Un plus 1 would equal the previous term to the new term, which is un. So if I want to work out this term, it would be this term plus the one before that one, which would be un minus 1. So that would be a way of notating the Fibonacci sequence. And again, I could write down that u1 was, let's say, 0, or and u2 is 1. So I can then work out what u3 is. Or I could say that u1 is, let's say, 2, and u2 was 5, just like we did in the previous example. So again, it's just a case of notation. Now, it's worth noting that sometimes in an iterative sequence, you can start with u0, which represents the initial value, and u1 being the next term. So, for example, if I look at a number bar, and I was to write down what number comes at the start of that bar, then we may say it 1, but we also may say it's 0. So then it starts at 0, but then the next term would be 1, next term would be 2, next term would be 3. Another way of looking at it is if you were standing here and apologies if this stickman looks nothing like you, then the stickman is at 0 because he hasn't moved. But when he makes his first step, like one step, he will then move to 1. So you don't always start at 1, you can always start at 0. And again, it can be very confusing, but hopefully that makes a little bit of sense. So let's have a look at some example questions. So now if I just zoom in, and let me just create a bit of space because I feel as if this may have been merged into one question. So here we've got 3 different questions, and all the questions asking us is to find the next 3 terms. So in other words, we've been given U1 and we want to work out what U2, U3, U4 is. So looking at question 1, we know that the formula is 3un plus 3. Now if I just highlight un, that's basically the previous term. So if I'm starting with u1 equals 2, now note that that's been given to me in the question, then to work out u2, what I need to do is multiply 3 by the previous term. Now the previous term is 2, so that's going to be 3 times 2, and then I need to add 3, which is what the formula initially is. So let me just effectively use colours. So then working that out, I get an answer of 3 times 2, which is 6, plus 3, which is 9. So u2 equals 9. Then for u3, again, I'm going to use this formula, which is 3 times the previous term. Now note that the previous term is now changed from 2 to 9. And then I need to continue to add 3. So 3 times 9 is 27, plus 3 is 30. Then to work out u4, again, substituting it into the formula, I've got 3 times the previous term, which is u3, which u3 value is 30, and then I'm adding 3. So 3 times 30 is 90, plus 3 is 93. So there I have my u3 values of 30 and a u4 value of 93. So moving on to question 2. So with question 2, our formula looks like un plus 1 equals un over 2 plus 4. Now un is the previous term and un is my new term. So again, starting with the initial value of, starting with a value of 4. So u1 equals 4. So u2 is going to be the previous term, which is 4, divided by 2, because you always divide by 2 because that's the formula, and then add 4. So 4 divided by 2 is 2, plus 4 is 6. So then to find u3, I substitute the previous value, which is 6 this time. I divide that by 2, and then add 4. So 6 divided by 2 is 3, plus 4 is 7. Then to find u4, I do the previous term, which is 7, and I then divide that by 2, plus 4, so that's 3.5 plus 4, which equals 7.5. So there's my u2 value, there's my u3 value, and there is my u4 value. Now to find, with regards to the next one, so let me just zoom down a little bit. So for this one here, I've got un equals un minus 1 squared over 2. Now un minus 1 is the previous term, and un now is the next term. So here we're starting off with u1 equals 2. Now because I'm squaring the un value, I'm just going to put that in brackets. So here u1 equals 2. So to work out u2, it's going to be 3 times the previous term, which is 2 squared, divided by 2. So that's going to be 4. So 3 times 4 is 12, divided by 2 is 6. Then u3 is going to be 3 times the previous term, which is 6 squared, divided by 2. So 3 times 6 squared, so that's going to be 3 times 36, which is 108, divided by 2 is 54. Then for u4, it's going to be 3 times the previous term, which is 54 squared, divided by 2, and 3 times 54 squared gives me an answer of 8748 divided by 2, which gives me an answer of 4374. So my answers for U2 is 6, U3 is 54, and U4 is 4374. So again, let's just have a look at some exam style questions. Hopefully you can spot a pattern. So for this, it says a sequence is defined by the term-to-term rule, and here we've got a iterative formula. If you're not sure if it's not come up brilliantly on the screen, apologies, but it looks something like this. Now again, if you've got UN, what you might want to do is maybe put that in brackets, like so. And the question is asking if U0 is -3. So let me just write with a thicker pen. And we know that U1 equals, or U0 I should say, is -3. So the question is asking us to find U1 and U2. So if I write this as U1, which is part A, and then U2, which is part B. Now for this value here, what I need to do is substitute -3 into this formula. So this is going to be -3 cubed plus 2. And now if I type that into my calculator, well, -3 cubed is -27. And then plus 2 is going to give me -25. Then for this U2 value, it's going to be the previous term, which is U2, which is U1, which is -25 cubed plus 2. Now if I put that in brackets, -25 squared, or cubed rather, plus 2, I get an answer of -15623, and there is my value of U2. Then moving on to question 2, it says sequence is defined by a term-to-term rule, and here we've got another rule. So again, just rewriting that so it's a little bit clearer on the screen. So it says UN plus 1 equals UN squared plus 3. So again, if you want to, you could put brackets around that. So for A, my U0 value is 1. So then to find U1, I do the previous term, which in this case is U0, so that's 1 squared plus 3. So that's going to give me 1 plus 3, which is 4. Then for B, U2 is basically, I'm going to substitute U1 into this. Now I've already worked out that U1 is 4, so I can rub that out and swap that with 4. So it's going to be 4 squared plus 3. 4 squared is 16, plus 3 is 19. Then for U3, well, that's going to be U2 squared plus 3. Now I know what U2 is because that's 19. So I can rub that out and change that for 19. So it's going to be 19 squared plus 3. And 19 squared plus 3 gives me an answer of 364. Then moving on to our next examples here, we've got a bigger or a longer, what some may say is more confusing rule. So we've got UN plus 1 equals UN squared minus 3UN plus 1. Now again, what I'm going to do, just to make things a little bit easier, I've just put brackets around the UN. So then, and we know that U1 equals 3. So for part A, to work out U2, that's going to be U1 squared minus 3 lots of U1 plus 1. Now I know that U1 equals 3, so what I can do is I can rub that out and swap that with a 3, rub that out and swap that with a 3, so that then becomes 9 minus 9 plus 1, which equals 1. Then for B, what we need to do is just repeat the process. So here we've got, if I just write down the formula again, so here it's going to be U3 equals U2 squared minus 3 lots of U2, or the previous term, plus 1. So U2 we've already worked out is 1, so that's going to be 1 squared minus 3 lots of 1 plus 1. So 1 squared is 1, take away 3 is minus 2, plus 1 is going to give me an answer of minus 1. Then for C, just repeating the process. So again, if I want to write down the formula again, so it's going to be u3, the previous term, squared, minus 3 lots of u2, 3 rather, and plus 1. And again, what I'm doing there is just swapping u3 with the previous term, which is minus 1. So here, minus 1 squared is positive 1. Minus 3 times minus 1 is positive 3. Plus 1 gives me an answer of 5. Then moving on to our last example. So again, apologies if this has not come up clearly on the screen, but what it looks like is this. It looks like this. And we know that our x0 value is minus 2.5. So for part A, to find x1, now x and u just the same, just using different letters. So here I've got x1 equals, and it's going to be 1 minus 3 over the previous term, which is x0 squared. So now substituting this into this, then what I end up with is 1 minus 3 over minus 2.5 squared. Now when you're dealing with negatives, especially on the calculator, always use brackets. So then typing that into my calculator, I get 1 minus and then 3 over bracket minus 2.5 squared, and if I press equals, I get an answer of 13 over 25. So that becomes 13 over 25, or if I wanted to write it as a decimal, 0.52. So then to work out x2, it's going to be 1 minus 3 over x1 squared. Now again, x1 is 0 minus 0.25. So that becomes 1 minus 3 over the previous answer, which is 0.52 squared. And again, if I type that into my calculator, I get an answer of minus 1706 divided by 169, or as a decimal, it's a long decimal, minus 10.0946746. So then to work out x3, well, that's going to be 1 minus 3 over x2 all squared. So that's going to be 1 minus 3 over minus 10.0946 blah 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 squared. Now I've still got that written on my calculator, so if I then do 1 minus 3 over and use the ANS function on my calculator, I should get an accurate answer. Otherwise you might have to use a rounded number, in which I get 0.970560081. Now I could have rounded any of those decimal numbers up, because then the question doesn't tell me what to give my answers to. So again, if you want to round it up, you can do, just always make sure you state what you've rounded it to. So for example, with this number here, I could have written x2 equals minus 10.1, that's to 1 decimal place, and x3 would be 1.0 to 1 decimal place. So if you have rounded it up, make sure you do, but because the answer is going to be quite long decimals, I certainly wouldn't pick 1 decimal place. I'd maybe go for 2 or 3, and worst case scenario, if it doesn't mention anything about rounding, just copy the number on your calculator or use the fraction that comes up on your calculator.